Hello everyone and welcome to my channel. I am Kshitija Wadverao. Currently I am studying Computer Science Engineering from Sri Siddheshwar Women's College of Engineering, Solapur. This video is concerned on Engineering Mathematics M1. I am here to share an interesting and important topic, that is linear algebra matrices. We will be focusing on matrix, rank of a matrix and normal form of a matrix. So let's start. What is a matrix? A set of mn real or complex numbers arranged in a rectangular array having m rows and n columns is called. What is a matrix? A set of mn real or complex numbers arranged in a rectangular array having m rows and n columns is called as m by n matrix. The numbers are being enclosed by brackets and the order of the matrix is read as m by n. Generally, the matrix is denoted by capital letters. Let us consider a 3 by 3 matrix. So, in general, we write matrix A is equal to A11, A12, A13, A21, A22, A23, A31, A32, A33. Let us see the example. 2, minus 1 and 3 are the elements of first row of the matrix. 2, 4, 3 are the elements of first column of a matrix. That is, row is the elements of horizontal elements of matrix and column is the vertical elements of the matrix. Here 2, 5 and 7, that is A11, A22 and A33 are the principal diagonal elements of a matrix. Let's move forward on rank of a matrix. Rank of a matrix is denoted as small r or row. The rank of matrix is nothing but the number of non-zero rows after reducing the matrix into standard form or identity form. Let's see the example. Here the rank of the matrix will be 2 because the third row is completely all elements are 0 and first row and second row are non-zero rows. So rank of A will be 2. A note to remember. For identity matrix having order 3, the rank of the matrix will be also 3. That is, the order of the identity matrix is equal to the rank of the matrix. Let's move to the normal form of a matrix. Every non-zero matrix of order m by n and rank r can be reduced to normal form by means of elementary row and column transformation. The procedure to reduce given matrix to normal form is we will see in detail. Step 1 is to check if A11 is not equal to 1. If A11 is not equal to 1, then interchange suitably 2 rows or 2 columns so that A11 becomes 1. If 1 is not present in the entire given matrix, then divide throughout the row or column by the number itself so that A11 becomes 1. Now second step is to perform row operation. Perform operations like R2 such that R2 plus K R1 or R3 such that R3 plus K R1. We will take help of R1 because A11 is 1 and it becomes easy. We will do addition or subtraction like R2 plus K R1. K here is an integer. Step 3 is to perform column operation. Our motto now is to bring 0 in the first element of column 2 and column 3. Fourth step is to bring 1 in the A22. If A22 is not equal to 1, then change the rows or columns suitably so that A11 becomes 1, but without disturbing the above elements. Step 5 is to perform row operation to bring 0 in the second column. Step 6 is to perform column operation to bring in the second row. And last step is to convert A33 is equal to 1. We will see the detailed explanation of this by understanding an example. Here is the problem. The question is reduce the following matrix to normal form and hence find the rank of the matrix. So here it is the matrix. Now let's start to solve it. Solution. Let us consider by taking let A is equal to the given matrix. Now let's check if A11 is equal to 1. Here A11 is not equal to 1 because here A11 is 2 and 2 is not equal to 1. So we will start by looking the rows and columns where we can change. Here are two cases. First is we can change R1 and R2 or column 1 or column 3, that is C2 and C1 and C3. So we will do row operation here. We will interchange R1 and R2. Remember, when we are doing row operation or column operation, we are not just changing the element but the whole row or column. So we will change the whole row, all the elements of the R1 and all the elements of R2. We will interchange so that A11 becomes 1. Now next step is to bring 0 in first element of second row and third row. The first elements of second row and third row are 2 and 3. So our motto is to bring 0 there. So we will do row operation. Row operations of type R2 such that R2 minus 2 R1. Look at that. 2 minus 2 into 1. Take help of R1 because R1 here it's already 1. So it will become easier. 2 minus 2 into 1, it becomes 0. And similarly, 3 minus 3 into 1 becomes 0. Now here, we are not just changing the elements but we are changing the whole row. If we are applying R2 such that R2 minus 2 R1, then complete entire row. That is, if first elements become 0, then the second element, that is 3 minus 2 into 2. 3 minus 4 becomes minus 1. And 1 minus 2 into 3. 1 minus 6 becomes minus 5. Similarly, third row, that is 1 minus 3 into 2. 1 minus 6 becomes minus 5 and 2 minus 3 into 3 becomes 2 minus 9 becomes minus 7. Now our next motto is to bring 0 in the first elements of second column and third column. Now we will do column operations like C2 such that C2 minus 2C1 and C3 such that C3 minus 3C1. Now let's see, the first elements of C2 and C3 are changed to 0 but other elements are the same because we are taking help of C1 and the elements of C1 are here 0, so none of the elements changes here. Now next step is to bring 1 in A22. Here A22 is not equal to 1. A22 is equal to minus 1. So simply multiply the whole second row by minus 1. It becomes minus 1 into minus 1 plus 1 and minus 5 into minus 1 becomes plus 5. Now next step is to bring 0 in the second column. So we will do row operation. The A32 element, that is minus 5, we will have to change it into 0. So we will do row operation R3 plus 5 R2. We will take help of R2. Whenever we are changing R3, take help of R2 because it will become easier because A22 is already 1. Now minus 5 plus 5 into 1 becomes 0 and minus 7 plus 5 into 5, that is minus 7 plus 25 becomes 18. Now our next step is to bring 0 in the second row, that is A23. The element is 5. Now we will change the column. We will do column operation. Now we will do column operation C3 minus 5 C2. It becomes 0 and 18s remain as the same. Now last step is to do A33 is equal to 1. Now divide the same number, divide the entire row or column by the same number. That is C3 divided by 18 becomes 18 by 18 is equal to 1. Now the matrix is reduced into normal form or identity form. Here it is an identity matrix of order 3. So remember the note for identity matrix. If the order of the element is order of the matrix is 3, then the rank of the matrix will be also 3. So here we have solved the problem. We have converted the given matrix into normal form, and the normal form we got identity matrix of order 3. So rank will be also order 3. So this was all about matrix, rank of a matrix and normal form of a matrix. Thank you for watching.